Welcome to this comprehensive exploration of 3I Atlas, the third confirmed interstellar object to grace our solar system. Discovered in the summer of 2025, this enigmatic comet-like visitor has captivated astronomers worldwide, offering a rare glimpse into the building blocks of distant planetary systems. In this detailed article, we'll journey through the discovery, trajectory, scientific observations, and profound implications of 3I Atlas. We'll also examine the broader context of interstellar objects that have entered our solar system, highlighting how these cosmic nomads are reshaping our understanding of the galaxy. Interstellar objects, or ISOs, are remnants from other star systems, asteroids, comets, or even fragments of planets, ejected into the vast emptiness between stars. They drift through the Milky Way for millions or billions of years until, by chance, they pass through another system like ours. As of September 2025, only 3 such objects have been confirmed passing through our solar system. But with advanced telescopes like the Rubin Observatory now online, we may soon detect dozens more annually. These visitors are not just curiosities. They carry pristine samples of extraterrestrial chemistry, revealing how planets form and evolve far beyond our sun. In the video, we'll break this down section by section, with visuals of telescope images, animations of trajectories, and expert interviews. Buckle up. This is a story of speed, age, and the unknown, spanning billions of years and light years of space. On July 1, 2025, the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS, telescope in Rio Hurtado, Chile, captured an unusual fast-moving dot in the night sky. ATLAS, a network of 4 robotic telescopes designed to detect near-Earth asteroids that could pose collision risks, routinely scans the heavens for threats. But this object, initially designated A11PL3Z, stood out immediately due to its blistering speed and unusual path. Larry Deno, a key figure in the ATLAS team at the University of Hawaii, was reviewing the data when the anomaly appeared. It looked like a completely routine discovery at first, Deno later recounted. But follow-up analysis revealed something extraordinary. The object was not bound to our sun's gravity. Within hours, astronomers worldwide were alerted, and pre-discovery images from other ATLAS telescopes and Caltech's Zwicky Transit Facility, ZTF, at Palomar Observatory extended observations back to June 14, 2025. Amateur astronomer Sam Dean and the Deep Random Survey team played a crucial role, confirming the interstellar trajectory through archival data. The object's path was obscured earlier by the dense star fields of the galactic center, explaining why it wasn't spotted sooner. By July 2nd, the Minor Planet Center (MPC) officially designated it as the third interstellar object, 3I Atlas, where 3I signifies the third confirmed ISO, and Atlas honors the discovery team. It also received the cometary designation C/2025N1 Atlas. Unlike its predecessors, 3I Atlas was detected inbound, well before its closest approach to the Sun, giving scientists months to observe it, a luxury not afforded to the first 2 visitors. This early detection has allowed for unprecedented study, from ground-based telescopes to space observatories like Hubble and JWST. 3I Atlas is on a highly hyperbolic trajectory, meaning its path is an open curve that brings it into the solar system without being captured by the sun's gravity. When first observed, it was about $4.50 astronomical units. $1 is the Earth-Sun distance from the Sun inside Jupiter's orbit, traveling at approximately 61 kilometers per second, 137,000 miles per hour, or 221,000 kilometers per hour, relative to the Sun. The hyperbolic excess velocity, V infinity. This speed will peak at perihelion closest solar approach on October 29, 2025, at 11:44 Universal Time, reaching 68 kilometers per second, before it slingshots out again. The orbit's eccentricity is an astonishing 6.14, far exceeding that of 1I/Oumuamua 1.2 and 2I/Borisov 3.6, making its path nearly straight through the inner solar system. It approaches from the direction of Sagittarius near the Milky Way's galactic center, on a trajectory inclined less than 5 degrees to the ecliptic plane, unusually aligned with our planet's orbits. Key milestones. Closest to Mars, October 3rd, 2025, at about 0 Australian dollars and 20 cents, 18.6 million miles or 30 million kilometers. Closer than to Earth, minimum 1 Australian dollar and 60 cents or 150 million miles. Perihelion, 1 Australian dollar and 36 cents in the Sun, inside Mars orbit, but safely distant from Earth. Outbound visibility, reappears in early December 2025 in the morning sky, passing near Virgo and Leo before fading beyond Jupiter by March 2026. This path poses no threat to Earth or other planets, but offers opportunities for Mars-orbiting spacecraft like ESA's Mars Express and ExoMars Trace Gas Orbiter to image it using instruments like HRSC and CASSIS. NASA's Perseverance, Curiosity, and Mars Reconnaissance Orbiter may also contribute, potentially revealing shape and composition details. Early estimates pegged 3I Atlas at up to 20 kilometers, 12 miles, across, but refined observations have scaled it down. Hubble's July 21, 2025 image, taken when the object was 277 million miles from Earth, shows a teardrop-shaped dust cocoon around the nucleus, with streaked background stars due to tracking the moving comet. The upper limit on the nucleus diameter is now 5.6 kilometers, 3.5 miles, possibly as small as 440 meters, 1,444 feet. Rubin observatory data from late July suggested around 10 to 11 kilometers, but Hubble's resolution refined this further, confirming it's the largest known ISO, up to 14 times bigger than 2I/Borisov, 1 km, and far larger than 1I/Oumuamua, 0.2 km. Classified as a comet due to activity at 4 Australian dollars and 50 cents. 3I Atlas shows a reddish coma, up to 26,400 x 24,700 kilometers, twice Earth's diameter, and a faint, sunward-pointing tail, unusual, possibly due to heavy particles not deflected by radiation pressure. Test data hints at activity as early as May 7, 2025, at 6 Australian dollars and 40 cents. No outbursts yet, but closer solar approach could trigger them, like Borisov's fragmentation. JWST's August 6, 2025 NIR spec observations revealed an unusually high CO2 to H2O ratio, among the highest in any comet, and a carbon dioxide fog in the coma, suggesting a different formation environment. Sphere-X data, August 7th to 15th, confirmed comet-like features but no tail, with potential variations in water to CO2 ratios compared to solar system comets. High nickel and CO2 abundance indicate an ancient, low metallicity origin. Dust loss rate matches comets detected at 300 million miles, but its interstellar journey implies a thick, radiation-hardened crust. Gemini North images show a compact coma, confirming icy composition. Since discovery, over 122 observations from 31 observatories have poured in. Key telescopes include Hubble, sharpest images, size constraints, and dust plume analysis. JWST, chemical composition, high CO2, scheduled for December 2025 post-perihelion spectroscopy. Rubin, pre-discovery images, coma and dust details. Gemini North/South, color filters reveal reddish dust. Public live views via Shadow the Scientists. Very Large Telescope VLT, cometary activity confirmation, high nickel and coma. Allen Telescope Array ATA, radio monitoring for emissions, no artificial signals. Nordic Optical Telescope and Tide Observatory confirmed diffuse activity on July 2nd. Interstellar Citizen telescopes detected it via stacking despite faintness. Age estimates, 67% chance greater than 7.6 billion years old, from Milky Way's thick disk of ancient stars, possibly 3 to 11 billion years. This predates our 4.6 billion-year-old solar system, making it the oldest comet observed. Trajectory simulations suggest encounters with 25 stars in the last 10 million years, accelerating it via gravity assists. Controversy. Avi Loeb speculated alien probe due to size, trajectory, and glow, but consensus is natural comet, no anomalous signals. As of September 2025, 3 confirmed ISOs have entered our solar system. 1I/Oumuamua, 2017. Discovered October 19, 2017 by Pan-STARRS 1. Cigar-shaped, 400 m long, 10:1 aspect ratio. Reddish, no coma but non-gravitational acceleration, possibly H2 outgassing. Eccentricity 1.2. V infinity 26 kilometers per second. From Lyra direction. Age 1 billion years. Thin disk origin. Sparked alien probe theories debunked. 22I/Borisov 2019. Discovered August 30th, 2019 by Gennady Borisov. Comet with CN, C2 gases. Fragmented in March 2020. 1 km nucleus, eccentricity 3.6. V infinity 32 kilometers per second. From Cassiopeia. Age 1.7 billion years, thin disk. Similar to Oort cloud comets. 3 I-Atlas 2025, as detailed above. Largest 5.6 km max. Fastest V infinity 58 to 61 km/s. Eccentricity 6.14. Active comet from Sagittarius/thick disk, potentially greater than 7 billion years old. No confirmed ISOs in 2024. Candidates like Centaur's, e.g. 2017 SV13, remain unverified. Rubin Observatory may detect 5 to 50 more in the next decade. 3 I-Atlas challenges models of ISO populations, suggesting ejections from ancient systems are common. Its high CO2 hints at water-rich, low-metallicity origins, informing exoplanet formation. As a thick disk relic, it probes early galaxy chemistry. Future. Hubble/JWST post-perihelion spectroscopy for S/O ratios. ESA's Comet Interceptor, 2029 for future ISOs. Rubin could find one monthly. These objects remind us the galaxy is dynamic with sextillions of wanderers. 3 I-Atlas is a bridge to other worlds. 3 I-Atlas isn't just a comet. It's a time capsule from a galaxy's dawn. As it exits our system, it leaves a legacy of discovery. In the video, join us for simulations, expert insights, and Q&A. What do you think, alone in the cosmos, or just the beginning? Subscribe for more cosmic journeys.